Good morning, ladies and gentlemen. A warm welcome to one and all present here. Today, we gather for the special inauguration function of the Global Initiative on Academic Network, Ministry of Education approved course on Artificial Intelligence and Machine Learning Algorithms, a comprehensive study scheduled from 15 to 19 September. In today's context, artificial intelligence is the biggest driver of technological change, enabling data-driven decisions and transforming every sector of the society. With the increasing availability of data and the rapid growth of computational power, AI and machine learning have been emerged as critical tools to design algorithms that learn, adapt, and perform beyond pre-programmed rules. This course is being coordinated by Professor Gautam Apana, Associate Professor and Head of Computer Engineering at GDU, School of Engineering and Technology, Ahmedabad. With multiple patents, funded projects, and over 60 publications, his research focuses on AI, IoT, 5G, 6G, and antenna engineering. Supporting him as course coordinator is Professor Anu Gokhale, Professor at St. Augustine's University, USA. Together, their expertise provides a strong foundation for this course and sets the stage for a meaningful academic exchange. It is my privilege to introduce Dr. Anu Gokhale, Professor and Chair of Computer Information Systems at St. Augustine's University, USA. She has over 3 decades of academic and research experience with 4 prestigious Fulbright Awards in data analytics, cybersecurity, STEM, and computer engineering, a 2023-24 Convergence Fellow, and former distinguished professor at Illinois State University. She has led international research teams across the US, India, China, and Brazil, with a continuous stream of NSF-funded projects. An accomplished author, IEEE leader, and globally sought-after keynote speaker, Dr. Gokhale has visited over 25 countries, delivering impactful workshops on AI, STEM, policy, and data analytics. We are honored to have her here with us today as she delivers the first lecture of this course on the evolution of algorithms from computer programming to machine learning. I would also request everyone to please maintain decorum and refrain from using mobile phones, since this will be a live recorded lecture and recording will be provided. Thank you.
Okay, good morning everyone. It's truly an honor to be here as part of the GIAN, which is the Global Initiative of Academic Network, a program conceived by the Government of India. And thank you to GTU for inviting me here, Gujarat Technological University. Without much ado, let me begin. The course is AI, of course, artificial intelligence and machine learning algorithms. A comprehensive study goes over a week from today until Friday, and it will be taught by me as well as Professor Makwana. Okay, first of all, let's begin with acknowledgements or gratitude. As I said, I'm truly grateful to the Global Initiative of Academic Network. It's a program, as she mentioned, by the Ministry of Education, Government of India. So what a beautiful way to design a program to tap the pool of scientists internationally, to encourage that engagement with the institutes of higher education here in India, so as to elevate India's scientific and technological capacity to global excellence. GTU is to be commended for taking advantage of this opportunity. Not all universities are able to invite folks. So GTU initiated this alliance, and I'm grateful to the GTU leadership team for being here. What? Oh, yeah. Sure. Fine. Come there. And I've been to GTU before, actually as a Fulbright specialist, to design and launch the master's degree program in cybersecurity in 2017. And so at that time, I designed the curriculum and teaching learning pedagogy for the master's program. One of the sustainable outcomes that I would call, that something makes me proud was that I established a cybersecurity advisory board, which comprised of business and industry specialists and faculty from other institutions to meet annually and provide strategic insight to achieve program goals. I hope that advisory board is still in session and continue. So I'll be learning more about it during my visit here. Okay. Just a little bit about years, and at ISU, Illinois State, for 25 plus years. My scholarly work actually is of three interrelated areas. One is algorithms and data analytics with applications across various sectors like security, computer networks, e-communications, and more. Effective ways to enhance students' critical thinking skills, because that's one of the important things that faculty ought to do, not just research, but teaching as well, to have the next generation of scholars. And the third thing, of course, is creating an inclusive environment in STEM. STEM is, of course, science, technology, engineering, math. And inclusive means not just across race and culture, but also across rural and urban areas and socioeconomic strata. So all different diverse populations coming together and elevating and building a community of learners. And that's what we are going to do here as well. Okay, so today's day one. It's 15th September, Monday, and the first lecture is from 10:30 to 11:30 on the evolution of algorithms from computer programming to machine learning. Okay, so that's the title slide. Okay, so here's an outline of lecture one. We prepare ourselves. I always believe that we have to first prepare ourselves for learning. So we'll do that body, mind, spirit with 1 minute silence. I call it a 1 minute meditation. And then we'll talk about who are the stakeholders for this course, okay? Introduction to algorithms, then we go into traditional versus ML, machine learning algorithms, overview of the types of algorithms, introduction to algorithmic bias, because that's one of the things that we need to, get started on. Then we'll have a wrap up and takeaways. Finally, course goals. The first lecture, we have to set our goals. I have to set my goals, you have to set your goals, so we'll talk a little bit about that. Okay, and so let's get started. Prepare ourselves, mind, body, spirit. Who better to quote than Swami Vivekananda, right? Who brought the East and West together. The power of meditation gets us everything. That's his quote. And so let us prepare ourselves. I brought a timer specifically just for that. And I'm going to begin the timer. And when this rings, okay, so everybody, including me, 1 minute silence, okay? Okay, so let's talk about the stakeholders for this course. Let's begin with some humor, right? Humor always is important to set our minds relaxed. Cell phones really can increase your efficiency. Just turn them off. And I'm going to silence my phone as well. Of course, I don't get many calls here. Who are the stakeholders for this course? Majority of the participants of this course are born between 1980 and 2000, correct? Most of you can identify with that range. Okay, great. Members of this group are often referred to as the millennials, net generation, or generation Y. Okay? So, millennials, what are their positive characteristics? Curious, excited to learn new skills, and willing to invest the time. That's why you are here, right? Okay. Collaborative, prefer to work with peers and teams and like open office spaces. Nowadays, if you go in any business or industry, they are going to see a lot of cubicles. Cubicles don't have doors, right? A lot of long tables with just chairs and just, laptops. They bring their own, plug it in. And so a lot of collaborative work. Nobody programs in individually. It's all teamwork, right? We have stand-up meetings every morning, so on and so forth. Open-minded, care about social causes like social equality and access. So we all care about the environment, all the social paradigms, and technologically savvy, of course, born with the internet and cell phones went mainstream. Like, the World Wide Web came about in 1991. So, when some of you born in 80 were like 10 years old. So it was like, it was the thing. And then everything went really upscale after that. Millennials, negative characteristics. Now, for negative characteristics, I have to say something. I have to give you a reference. For positive, you might not ask me, where did I get that? But for negative, you're saying, who's saying that? So I made it sure to give you a reference. Described as lazy and narcissistic. What is narcissistic? It basically means self-centered and egotistical. Okay, so I'll leave it at that. I'm not going to comment anything. Some of you might identify with that a little bit. Some of you might not. You might say, what? Because what's in us, we don't always realize, right? The mirror is never up. Young people have been rewarded for minimal accomplishments such as mere participation in competitive sports and unrealistic expectations of working life. So we get nowadays certificates of participation. Like, hey, you came, great job here. So that's something new. Of course, there is a plus side to that. It's also a motivation. So I'm not any way, criticizing that at all. Just mentioning facts. Okay. So every time I have a reference, more emphasis on extrinsic values such as money, fame, and image, and less emphasis on intrinsic values such as self-acceptance and group affiliation. Okay? And just something for us to ruminate on. So millennial generation, is it hype or reality? Just with a cartoon again. Hi, sweetie, how was your school today? Dad is asking. And what does the child say? You can read all about it on my blog, Dad. So rather than talk in person or anything, it's all about social media. Everybody, sometimes people text each other even being in the same house, right? Rather than go and talk to somebody. So something we need to keep in mind. Only by understanding the millennials, all of you, can instructors like me create learning environments that optimize their strengths and minimize their weaknesses. So it is important that I design the course with you in mind. And that's why I'm bringing all this up. Yeah? Technology has changed the millennials, generation Y, but how has it changed? What are the differences between millennials and generation X, the educators generation, as I call it, born between 1960 and 1980, and that applies to me. Who are the millennials? Of course, we talked about born between 80 and 2000 and beyond. So some of you might be born even after 2000. That is highly possible. 80 million in the US, at least, most ethnically and racially diverse populations because of all the interracial marriages and even common here nowadays, right? All grew up with technology, and then dominance of social networks. Of course, the social networks change every day, so don't take what necessarily on here, all the new Instagram and something that might come up tomorrow. Okay. Why do they matter? Because we need to make a difference with the work. So it's like employers need to know what your aspirations are to make you feel good about the work that you are doing. Have job satisfaction, and instructors the same way. You feel good about what you're learning and in your style, and so you have high expectations, achievement oriented, confident, and we need to capitalize on your strengths and also address a little bit about the weaknesses. Okay, so that's what I believe in, capitalizing on your strengths. So some humor again. The millennials are testing much better since we changed true or false to like or dislike. So lot of thumbs up or thumbs down. Views of different stakeholders about readiness of graduates for the job. It is important that we talk about the outcome at an institution to get a degree. What does the degree do? Open up opportunities. Employers say what the providers are the institutions, and youth would be you all, students. So overall, an employee is being hired is a bachelor adequately prepared by the education or grade. So that's what is the question what employers are responding to. What are the providers or institutions responding to? And graduates from our institution are adequately prepared for every level positions in their chosen field. So if the graduate, yes, they are prepared. Yes, to what extent? So overall, I think I'm adequately prepared. That's what you are asking, or you are saying. Okay, so let's see what the outcome is. Employers say 42%. Providers think, hey, they are ready. 72% think you are ready. But you yourself, you're not quite sure. So 45% of you think you're ready. So that aligns more with what employers think as well. But let's see what if there are differences in perception between what employers think and what students think on the proficiency in the readiness for employment. Okay. So for competency, and then percentage of employers that rated recent graduates as proficient, while what students thought as themselves as proficient. Okay, so professionalism or work ethic. The work ethic is not as much as what employers would desire, but the students, of course, the graduates feel, hey, we have great work ethic. Oral and written communication skills the same way. I think the oral, I'm not sure, but written communications are certainly lacking. I can say that for the US as well. And one of the reasons for that is there is a lot of with AI, of course, the chat GPT is going to create research papers for you or whatever. And there's always a copy and paste kind of thing. Even before the chat GPT was around, over the last 10 years, we have to be so careful. Like people will pick literally paragraphs from references and paste it in their reports rather than paraphrasing what was said. So there is no paraphrasing. It's simply lifting something. And so the written communications are certainly something to be addressed. Even emails can be very, very informal rather than writing a formal thing, hello, whatever. You just write a message and send it off, or texting. And that has created the culture for less formal communications, I should say. Critical thinking and problem solving, I would say that's not that bad because, we always, the employers, even 55, anything over 50%, I consider that good. Teamwork, collaboration, like I said, you are all that is your strength, and that's great. I commend you for this new generation for that. The leadership, I think that just comes with age. It's like new graduates, of course, don't have the experience. Digital technology, you might think, hey, I don't know as much, but for employers, they think you are great. You are beyond what their expectations are for digital technology. So you are doing fantastic. Career management would be more like, hey, they come and they just go in 1 year, So are they actually managing? Are they thinking? So maybe I would say put some thought to your career. When you go with a goal. What is it that you want to achieve as part of your first job? Then what do you expect? Kind of make a trajectory for yourself for anywhere from 3 to 5 years. I wouldn't say make a 10-year trajectory. It's too long, okay? And everything is unpredictable. Even 5 years is kind of, I would say 3 to 5 years is quite good. Okay, so but have some plan in mind. Don't just go blankly somewhere. Okay, and I think global intercultural fluency is fine. Okay, so let's begin now with the actual content. Let's introduce algorithms. Some of you might already be familiar, but even then, bear with me if you are already familiar with it. So, what is an algorithm? Word used by programmers when they do not want to explain what they did. So you might think, oh, that's a joke. But later on, you'll see that there is some truth to that humor. Okay, there is a lot of truth, in fact, to that humor, because programmers literally half of the time or most of the time do not know. It's a black box. Okay, so they really do not know how the algorithm made the decisions or made the predictions that it did. So dictionary definition of an algorithm, of course, any well-defined computational procedure that takes a set of values as input and produces a set of values as output. A set of instructions for solving a problem or accomplishing a task, right? I mean, pretty much a textbook definition of an algorithm where you have input, output, and of course, we need to be sure anytime we are doing like, the diamond or the parallelogram, we need to be aware of how to represent different, I'm not saying the word because I know it's coming. One of my quiz has it. So it is like a roadmap. So roadmap, when we want to go somewhere, Google Maps, shortest route, fastest route. Fastest route may not be the shortest route, right? Somewhere you might have to take like turns and then it may be long, but still you will not be stuck in traffic. So, no, performance, how do you evaluate algorithms? Okay, performance characteristics of algorithms are very important. So the biggest one, the most important one is the run time or speed of computation. How quickly, if we are doing something and we have to wait, I'm like, what? How long is it taking? Even if it is 3 seconds, we might say that's too long. Okay, so we have to be aware that run time of the algorithm is very important. Speed of computation. Now that's always relative to the size of the input. So we have to remember, so a little while ago, you might remember like the AI, one of the like the inventors from China came up with a new algorithm where he used limited input, right? So rather than use that brings it up. The average runtime is the average of how long it would take the algorithm to run if all possible inputs were given, and if just some insidious, meaning just some crazy input was given, then it's just too much. Okay, it just takes too long. So basically, just remember that the speed of computation is important in any algorithm that we design. Okay, exceptions for inputs to the algorithm would be the limitations, of course, that we call always limitations in research. There may be special case in which the algorithm won't work or will produce unacceptable results. Like for example, here when I put Ahmedabad, Gujarat to Doha, why Doha? Because I came on Qatar Airlines. GTU made reservations for me, my airline. So, that was and there was no map. Although we know that you can go by road, there is a roundabout way of going, but any algorithm, we have to limited data, then it will say, oh, not possible. So why focus on algorithms? Why are we talking about machine learning algorithms? Okay, almost everything that we do in our life with any electronic device or e-device, and we are always with that e-device all the time, all of us, okay, relies in some way on an algorithm. So internet runs on algorithms, online searches are based on algorithms, hacking, cyber attacks, smartphone apps, travel websites, they wouldn't function without algorithm. Finally, online dating sites, if you use any online dating sites, then they also run on algorithms. Just a little humor about that. I'd like to meet the algorithm that thought we'd be a good match. So, not all one of those dating sites can produce the perfect match, right? So just a little. Okay, so traditional versus machine learning. So let's talk about the difference between the two. Okay, so we are talking about the transition from computer programming to machine learning. Remember, the first lecture is about that. So, how are algorithms traditionally represented? What would you call this? Anybody? Perfect, perfect. That's why I didn't say that word before. When we were talking about all the symbols, the parallelogram, the diamond, what we use it for, each one has a role in that. So, what would this be? Pseudocode. Perfect. Yes, exactly. Okay, so this is how traditionally we have represented algorithms, right? Anytime we do programming, it's all about flowcharts, pseudocodes, describe how an algorithm works, useful to explain the process to less technical users and when designing code in a team, correct? So you give like the skeleton basically. In addition to pre coded algorithms, there are self-learning and self-designing algorithms, and these machine learning algorithms are the foundation of AI. So now we are transitioning from the traditional programming to the machine learning algorithms. Okay? So an overview of types of machine learning algorithms, three broad categories: reinforcement learning, supervised learning, and unsupervised learning. We'll just do a overview today, then later on we are going to go more into depth about each, look at applications and so on and so forth. Okay. So reinforcement algorithm, process of shaping behavior of a digital agent by controlling consequences of the behavior. So consequences of the behavior, did the algorithm is going to ask, how did I perform? You say good or bad. Okay. So that is how the algorithm gets feedback on its performance, and then it decides the next step. So autocomplete, autocorrect, spell check, these are examples of that. So many times we will have an example and then it will say, when if you type please, it will say let me know, right? Okay, if I were to type someone's name like Makwana, it would change it to Mackinac. So, because, it's the US algorithm, it tries to do all the US names. So autocorrect, sometimes that autocorrect just makes me so mad because I'm like, that is not what I want, right? And every time then you have to go back and change it. So, um, robotics, including the robots that play games like chess, they are all reinforcement algorithms. So, like we have the chess, IBM Blue beat the Russian chess player, right? Okay, so that's all is part of the reinforcement algorithm, because when it makes a good move and you say, hey, good job, it is going to take that input and say, okay, I need to keep doing this. If it hits a ball, like, it will play football, it will play basketball. If it makes the goal, then it's going to say, okay, this was the right move, so on and so forth. Okay, all that is reinforcement learning. The second type is supervised learning. Infer a function from training data where each example is a pair of input and output. Next, generalize to test data or unseen situations. So basically what we have is divide the data set into two parts. One would be your training set, one would be your test set, right? Okay, and the training set, we actually train the algorithm using the training set, and then we test the performance of the algorithm on the test data. Okay, so an example would be, we would train the algorithm by saying, oh, this is a crescent, this is a circle, this is an oval, so on and so forth, okay? Or the ellipse. And then we say, okay, now tell us what is this shape, okay? And then it's supposed to give us the right answer, right? And if it cannot figure things out, then it has to decide on its own. Another example for supervised learning is also email classification. All our spam folders, they are all supervised learning. It will, and then how does it learn? When you say, oh no, this wasn't spam, move it to my inbox, then it learns, oh, okay, that's what I need to do. The second thing, something spam comes in your inbox, you're going to say, no, 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 this is spam. And that's how your algorithm is going to learn, correct? So this is basically always supervised learning. There is nothing like, oh, I don't know what I'm supposed to do. It knows, okay, this is your training data, this is your test data. For unsupervised learning, though, it is quite different. Infer a function from unlabeled data sets, exact output is not known in advance. Even the trainer like us, people like us who are creating the algorithm, don't know what is the right answer. Okay, that is unsupervised learning. When we know what the right answer is, that would be supervised learning because we are already had input, data, output. You have a question? Go ahead. Okay, a great question. The bottom line is we talked theoretically about reinforcement learning, supervised, unsupervised. A lot of real life algorithms are a blend of everything. So you can't really distinguish. Same algorithm can be used as a reinforcement as well as a supervised. Same algorithm can be used. It can be designed that way. So same thing with supervised versus unsupervised. I would say there is no black and white. It's more of a shade of gray. So you are right. There is a way of distinguishing between the two while not distinguishing and having them blend. Requires human intervention to correlate patterns with domain knowledge and label the groups. So, for example, we give it just all these items, okay, and then we say, okay, can you sort them? Well, what are the ways to sort these items that you see on the screen? What are different ways to sort them, just in general? Color, shape, size, excellent, excellent, absolutely. Small, big, medium, large, colors, of course, and then the shapes, circle, rectangle, squares. Okay. Self-learning and self-designing algorithms. So we are going to look at some supervised, unsupervised. Unsupervised are mainly used for clustering, association, dimension reduction. Supervised are typical classification, regression. Now, classification and clustering, you can think of, there's not much difference between the two. You'll just try to, distinguish. Okay. So I would say don't get stuck between, oh, which one should I be using, supervised or unsupervised? Don't get stuck on that. I would say look at what your data set is and maybe try different algorithms. So we are going to look at how to do that later in the course. Okay? Introduction to algorithmic bias. I just wanted to bring like a whole 9 yards in this first lecture, like, just introduce everything. We are going to look at more algorithmic bias later. What are the ways to overcome bias? Not just what it is, but ways to overcome it. So, what is a biased algorithm? Basically, algorithms are today replacing human decision making because they are perceived to be unbiased. Agreed? Oh, if the computer makes a decision, it has to be right. Hey, it wasn't me who made the decision. Look, I use the computer. Okay, I use this data. I didn't do anything, right? I mean, bank loans, if you go to a loan officer, the bank loan officer is going to say, nahi, aapka reject ho gaya. Hai na? So, no, your application was rejected for whatever reason. It wasn't me. The algorithm told me that it cannot be approved. So whatever it is, we just put it on the. But what is, after all, algorithms run on data. So we have to see what is that data that is actually enabling that algorithm to make those decisions. Here's an example. I'm your phone. I feed you filtered opinions to reinforce those you already have. So that's what it is. If you look at airfares for some place, immediately you're going to get hotels from that place, or you'll get luggage set ads, right, on your phone immediately. So that's what it is. It's going to just kind of make those predictions for you. So credits, now this is a real example, okay, a real life example, no names attached or anything, but it's a real life example from the US, okay, so which I'm going to share with you. Questions asked. Now, typically, when you go and apply for these store credit cards, like really simple, all they do is, oh, it's really simple. You go to Macy's, it's going to say, all we need is your name, address, income, give us your driver's license or something. They'll note down your name, they'll just run it, and in 1 or 2 minutes, they have the results. Okay. So that kind of thing. So for the same income, a white male in a certain neighborhood has a credit score of 9 over 10, while a black female in a different neighborhood has a score of 3 over 10. How is that possible, you might ask, right? I mean, we didn't ask for race, did we? Did we say white or black? No, Asian, nothing. We just asked for name, address, and income, right? How did it make that decision? So let's look, okay? What the computer does in its data set, it knows white names, black names, Asian names. My name is Anu Gokhale. It immediately knows, oh, Gokhale, 100% from India. Also Maharashtra. Also Maharashtrian Brahmin. All those details are going to come down. Okay. So just that whole data set is going to be categorizing things even without us saying. So it knows, oh, this looks like a white name, this looks like a black name, okay, this looks like an Asian name. Male names and female names, even us, we know if somebody's name Vikas, we know that would be a male name. John, okay, male name. Mary, of course, a female name. Okay. Neighborhood scores. If you live in a certain neighborhood and oh, that's an expensive neighborhood, right? We know that. These areas, oh, that's in, if I don't know that much about Ahmedabad, but in like Mumbai, where I was born and brought up, you live on Pedder Road, that's a good area to be in, okay? Stuff like that. So bias and human engineered, humans create or collect the training data, right? Who collects the data? It's us who collect the data. The computers don't go out and collect data. Humans decide what features in the data are relevant and important. So we say what the features are, we give them weights, correct? Weights is how much to value each feature, okay? So humans decide what you want to predict or classify and what you conclude from that. So ultimately, we are responsible for all this process that goes into it. And based on historical data, who has higher credit scores? I mean, even here, in the past, women didn't work, right? They were mostly stay-at-home moms. They did a lot of work at home, brought up kids, nowadays, you both work, so a lot of food comes from outside, right? If the female is at home, sometimes there can be male homemakers, and it's fine. There's nothing wrong with that. In the US, there is no much distinction, but in the past, even in the US, most of the males were work while the females stayed at home. So then who have higher credit scores? Obviously males over females, because they are the earning partners. What are the characteristics of this data set? And typically when the blacks came, there is a lot of history in the US of, slavery and so on and so forth. So it's the whites were the more privileged class, and, the African Americans weren't as privileged. So white names, male names, select neighborhoods. Even today, there are neighborhoods that are more expensive, golf course neighborhood, stuff like that. And center city, there would be a stigma for certain neighborhoods. So credit scoring algorithms always takes that into consideration. And many times, even if we can afford it, like somebody can afford it, you're going to stay very close to where your family is. Oh, my parents are settled there, my uncles, aunts, cousins. I'm going to stay closer rather than move somewhere else because it's a expensive neighborhood. If I don't see people like me, I don't feel comfortable being there. I want to see people like me, right? Yeah. So white names, black names, Asian names, white names are assigned higher weight. Male names, female names. Male names are assigned higher weight. And we saw the history for that. Why, right? So the computer is making decisions based on what it knows from data. And we fed the data to the computer. Okay. So neighborhood scores, select neighborhoods are assigned higher weights. So what is it going to do for the same income? Credit score difference between one and the other. And this is a real case that happened. Okay. So using proxies, is there a problem? Proxies is rather than ask directly a question, you ask it in a roundabout way. Okay, you ask something else and you actually conclude something based on that. Okay, so let's look. To predict outcome that we cannot measure, we use proxies. These are features that stand in for that outcome. So, will a student succeed in college? Now, what do you think happens when you apply to foreign institutions for admission? Okay, well, I mean, thousands, what if several few thousand applications are received for like few hundred seats, correct? So there's not a human actually going through the applications, agree? So it is made, decisions are made by algorithms. What are some of those factors that come into play when they look at the applications? You won't believe it, but obvious ones I didn't state, your test scores and this and that. But there is also something about socioeconomic status, your race, your gender, your religion, your immigration status, all that also comes into play when they think about what about your success factors for your, when they admit for success in college. So multiplying bias in algorithms are making decisions and those decisions become data for future learning algorithms. Bias decisions today become bias training data for tomorrow, right? Because that same data, like we saw in reinforcement learning, yeah, you're right. It's going to say, yeah, I got it right. I'm going to use that same mindset to make the decision. Mindset meaning the computer's mindset. So if we were doing traditional data analysis using statistical procedures, a number of questions could be raised because we can see what the data is and how many sample sizes, what the population. Your sample sizes are small, your standard deviations are high, your conclusions means nothing because standard deviation is high and small sample size. That's conclusion doesn't mean very much, and you should feel bad for presenting that study. But if you do it using an algorithm, machine learning algorithm, okay, there's not much questions that can be raised, So that's something we are here for. What are those critical things that we need to learn beyond just accepting what what the algorithm is saying, okay? So that's where the critical thinking comes into play for us. So some humor about data analysis, of course. I can prove it or disprove it. What do you want me to do? Because with the same data set, right? It's common. I always say politicians, you are from one party, are going to use that same data and twist it to say how great we are doing, but the opposite party is going to criticize you, right? The same data, same situation. So humor or some truth, you have to decide. Algorithm word used by programmers when they don't want to explain what they did. So wrap up and takeaways. Summary of lecture 1, evolution of algorithm from computer programming to machine learning. That's what our first topic was. So computer programming involves explicit instructions to achieve a specific outcome. Machine learning sets of rules that enable computers to learn from data. So data-driven models make predictions or decisions, improve their performance over time. Use of machine learning algorithms help explore, analyze, and find meaning in large, complex data sets. That's why actually machine learning came into play, because with such large and complex data set, big data as we call it, it's just not humanly possible to actually use any traditional ways. So course goals for all of us, okay? So what does this course mean to me? I'll begin with myself and then we'll talk about you. My goal to empower each participant, each one of you. Each one of you is an individual and I value each one of you. Okay, so if you come to me individually with any questions, queries, whatever, feel free. I'm not going to go away after my 2 lectures. I'm going to stay here for the whole day until the whole session is over for the day. I'll be here for lunch, so I'm available to talk over lunch or whenever we have breaks. So please feel free. Okay. Each with the knowledge and tools to use AI and ML to make a positive difference in this world, beginning with India. That's what you're here for. That's why the government of India is supporting this program, right? It's empowering you. So the whole idea for the government of India is to say, how is our next generation going to be technologically advanced, scientifically adept at doing what it wants to do? So it's your responsibility to take advantage of this opportunity. Okay. To inspire participants to imagine applications for AI and ML, something that's what entrepreneurship is all about. You have to think about, hey, what can be done, right? My commitment, give my all to the course and make GTU proud. So GTU has invited me and I want GTU to feel, hey, we are happy that she came, we invited her and it has made a difference. So that's what I'm here for. Okay, my goal is to make GTU proud. And my sentiments, we are on this mission together. Okay, you and me. I'm grateful to each one of you for your presence and your commitment to making this course a success for all of us. If I put my hand out, unless you put your hand out and shake with me, there is no handshake, correct? Okay, so I'm here to, making this commitment to make this a success for all of us. So what does this course mean to you? I want you in your own mind, over the break, at the end of the first day, not necessarily at this moment in time. Okay, you might need time to think, to reflect on it, define your goals, make a commitment, okay, to yourself, tap into your sentiments, because after all, a lot of thinking happens from the heart, right? Okay. Nothing can dim the light which shines from within. That's a quote from Maya Angelou. She's a very famous author in the US. Start on the journey. Big journeys begin with small steps. So thank you. Thank you, everyone. So we might have like 8 minutes or so for the questions, but typically in the US, the lectures are like 15 minutes. That's typical. It's never a full hour. So I design all my lectures like for 15-minute time frame. Okay. So if there is anything we can, otherwise we can actually stop the recording and then we can have Q&A, because it would be more informal. Then it's totally up to you folks. Yeah.
What is your expectations of this Y generation's unprecedented AI?
Well, I think my expectation would be for each one of you to see where can I make a difference. So each one of you has to decide, there may be things that you may come up with that I would never have thought. So, I wouldn't say, oh, you want to try to do this, try to do that. I would like you to come up with something, this is because your unique background, your unique expertise is going to create ideas within you. So, always, I think each one of you is empowered to do great work. I truly believe that. So, each one of you is empowered. Like, you have to use your, you know, whatever you are blessed with to come up with. So,
In that case, he can take a break and then he can begin. I have a lecture 2 planned, but that would be afterward.